Hello class, in this video we're going to be looking at explanatory and response variables. The learning intention of this video is for us to explore the differences between univariate and bivariate data, and for us to explore the terms explanatory and response variable. The first thing that I'll be talking about is univariate data. So when we looked at chapter 2, we were looking at univariate data, and univariate data is essentially where we collect observations for only a singular variable, okay? So if you look at these three graphs over here, these are examples of where we've collected and displayed univariate data, because all you're doing is collecting the frequencies for one particular thing that is occurring. For example, if you're looking at the histogram down below, what you're collecting is only the scores for the final exam. So again, just one thing. In a parallel box plot as well as a back-to-back stem and leaf plot, you've got two data sets. However, you're still measuring one particular variable. So if you look at the parallel box plots, you're only collecting frequencies on the test scores. Whereas for the back-to-back stem and leaf plots, what you're doing is you're collecting what is the heart rate before and after exercise. So again, only one particular variable. When we previously looked at univariate data, what we were doing was trying to describe the distribution in terms of its shape, spread, and center. However, from this point onwards, we're going to be looking at bivariate data, and the prefix bi means two. So in this case, bivariate data involves two sets of variables that we're going to be collecting and analyzing. And the purpose of bivariate data is for us to analyze, compare, and explain the correlation or the relationship between the two variables. And we can categorize the variables into two main types. The first type is the explanatory variable, or EV for short, and the other variable is referred to as the response variable, or RV for short. We define the explanatory variable as the variable that causes and explains a change in value in the other variable. So in this case, the response variable, and the response variable is defined as the variable whereby any changes you make to the other variable will ultimately affect this particular variable. So I'm going to use an example because obviously this definition might be a bit hard for you to understand. So what I've got over here is the temperature or the weather, and I've got ice cream sales as my two variables. Now, one of this is going to be the explanatory variable, one of them is going to be the response variable. In this case, the explanatory variable will alter and affect the other values for the response variable. So in this particular example, it makes sense that the weather or the temperature conditions is going to therefore affect the number of ice cream sales. So as a result, this is going to be the explanatory variable, and therefore the ice cream sales is going to therefore be the response variables. It's going to be a bit more easier when we look through a couple of more examples. So let's look at another example. In this example, it reads, Damon is investigating the relationship between the length of time passed and plant growth from a seedling. Both variables are measured numerically on a continuous scale. The question wants you to identify what is the explanatory variable and what is the response variable. So in these types of questions, what I tend to do is try to identify what is the explanatory variable. Remember that the explanatory variable causes and explains a change in value for the other variable, okay? So in this case, you've got the variables length of time passed and plant growth, okay? So which one of these two affects the other? Now, it's more logical and more sensible for the length of time to therefore affect the plant growth. So therefore, my explanatory variable is going to be the length of time passed, and the response variable is therefore going to be the plant growth. I would now like you to have a go at identifying what are the explanatory variables and the response variables. So have a go with this question and we'll go through the answers together. In this particular question, you've got two variables, the number of homework completed as well as test results. It makes sense that this particular variable over here is therefore going to affect and change the results for your test scores. So therefore, the number of homework sheets is going to be your explanatory variables, which is therefore going to be the answer for this question. Have a go with this question. In this question, you've got two variables, the number of seeds planted and the number of fruits grown. In this particular case, it's more logical for this to therefore affect this particular variable. So as a result, this is going to be my explanatory variable and this is going to be my response variable. As a result, the answer is going to be D. Have a go with one more question. In this particular example, you've got two variables, the number of songs stored and the memory capacity. And one of these will therefore alter the other value. In this particular example, it makes more sense for your memory capacity to therefore affect how many songs you've got stored on a media player. So therefore, my explanatory variable is memory capacity, and my response variable are the number of songs stored on the media player. What I'd like you to do now is I'd like you to please complete all the questions from exercise 7a. This is the end of the video. Thank you guys for watching, and I'll see you guys again in the next one. Bye.